Hello. Normally I'm working on audio and video equipment on this channel, but today I'm doing some domestics. Let me tell you a little bit about this. It's a Salter air fryer, which means basically it's a mini oven. This is one that's got a single drawer which is split into two compartments or can be reconfigured for one. There is another version of this with two compartments, and there's a chap who's covered that one on YouTube already. Now, this one was bought from Lidl. It worked fine for some time, just under a year actually, and then one side stopped working. All the display and everything works properly, but there's no heat on one side, which I gather is probably a thermal fuse failure. So we've got to take this thing apart. Now I said it's just under a year. Actually, Salter gave us a full refund, but didn't ask us to take it back to Lidl or anywhere else. So a sensible person would throw it in a skip, but we're not going to do that. We're going to see if we can fix it. Right, let's get stuck in. Start by taking the food part out. So we've got to dismantle this. The elements you can see here, there's two individual elements, and this right side is not warming up. I can't easily demonstrate that here right now in my workshop because my workshop power supplies got isolation transformers here for safety, and they won't be able to handle the load of this thing. I could plug it into raw mains, but take it from me for the time being that the right hand element doesn't get hot. We actually checked it with a thermal imaging camera. Right, so we've got to undo some screws. There are screws underneath and at the back, and some hidden ones under here, I believe. Let's start with the easy ones. So I've undone two at the back. I see 6 along the bottom here, and also 3 along the front edge. Okay, I think those front edge screws are very slightly longer than the others, so we'll keep them separate. So a tricky bit, I think, is going to be taking this front off here. Something I should mention, because this can be sold with two individual drawers rather than a single drawer, it actually has two separate interlock switches here, safety interlock switches. So in order for me to test just that one, I was able to just override that interlock switch and that side would heat up. Okay, that was probably the hardest part of the job, I reckon. So we have now disconnected the front panel and we can get to the rest of these screws. There's also some down here. I'm not sure if we need to undo those. We'll find out in a minute. And just for a moment, I'll disconnect the front panel. Squeeze the connector first. Okay, these are the lights. I think they might be light bulbs actually. Okay, there are individual motors for each side, and as we've seen already, the individual switches and lights. Right, so looking at what I believe is our common terminal here, this set here, which is labelled ACN3, between there and heat 1 is working, we see 50 ohms. But between there and heat 2, which is a white wire, we see open circuit. So that white wire goes over to here, and I think this is our thermal fuse. I'm also going to check that the fans make sense. So the fan 1 is 160 odd ohms and moves when I adjust it. And fan 2, because if the fan was broken that would cause it to stop working. It's 166 ohms and it moves when I adjust it on fan 1. But fan 2 is 400 ohms, seems a lot more, and also changes when I move the motor. But it's a big difference. That seems wrong. So I'm going to have to connect this back up again to some mains and see if I can make that fan run, because if the fan doesn't work, that would be a problem. Okay, I've put some of this back together at the front. I'm going to have to connect it to raw mains in the workshop, which I didn't particularly want to do. So we're going to go for side 2, which is our problem one, and just go for a very low temperature and see if that motor spins. Certain amount of time, start it. Is that making a funny noise? It certainly seems to be blowing though. What do you make of that noise? It could be just mechanical noise. Right, side 1 we're going to try on its own. Hopefully it'll let me do that. It's certainly quieter, but is that enough to make a difference? And I've started up again on side 2. I don't think there's a problem with that motor. Okay, let's carry on, but it is odd how the resistance was so different. Right, I'm going to carry on investigating the thermal fuse. Okay, so I'm now going to see if I can get down to the thermal fuse part, which isn't easy. There's a lot of dismantling involved, I believe. So I'll have to dismantle the front again. So we need to take this housing apart. There's no way to get to the parts we need from here, I don't believe. No, I'm going to have to take it apart. So there's a set of screws around the edge and any other screws we find as we go along. Or do I have to split this and the base by taking all these screws out? That's a possibility. Don't know. Let's see if I take these screws out, what happens. Now I mentioned there's been a YouTube video which I had watched on dismantling of these units, but it's a subtly different model, and these trays are totally different shape and it's just built in a different way. So we're on our own here. Okay, so I've undone these housing screws, but it's still trapped in by this vent at the back, which is itself attached to the PCB. So we'll have to take the PCB off. Right, now the vent housing at the back. Aha, now we have fairly good access to the heater unit. So this is the fan element, and here somewhere we'll have, that's the thermal sensor I believe, and the thermal fuse will be mounted somewhere in the back of this. Okay, let's disconnect the element a bit. Yes, I believe I need to disconnect this fan from the back, and this may be a anti-clockwise thread, so just be aware of that. And then hopefully I can withdraw this metal part from the plastic and get to the components that are mounted on the back here. We're going to have a problem with the wiring because these wires loop round from the element to this, so I'm going to have to disconnect one end or the other, and I don't know which end unplugs if either. That's going to be awkward. Alright, let's take this off. It is an anti-clockwise thread, but it wasn't done up very tight, so all I had to do was hold the blade and undo it. So we have a nut at the top, followed by a spring washer and a flat washer. Does that give us the freedom to move this thing, or is it still wedged in somehow? Yeah, the element is off and the fan is off, so what's holding it in now? Feels like this tray should be ready to move. It is. It's just these tabs here that are holding it in place. So looking here, it's almost as though there's two thermal fuses. I don't think there is, but one there and one there. But there are two sort of loop throughs, and I need those disconnected so that I can pull it apart, because the trouble is the wires from the element are going through to at least one of those connections. This would be easier for you to do than for me, because you'll have the benefit of knowing how to disconnect the element, but I don't. I have the element of surprise. So I can see that the terminal here that's marked earth is only earth, and that's not relevant. So what do I need to do? If I fold out these tabs here, straighten out those tabs, I may have enough room to pull through. Yes, that'll work. Let's do that. Let's straighten these tabs out. Okay, so I'm pushing these metal tabs through, which should release the whatever wiring is on the other side. Okay, that's done. So I should be able to pull these through the back now. So these are the tabs that were pushed through the frame. So I'll take them out. Now I would be able to pull them straight through, but unfortunately one of them is caught around the earth wire, which is possibly just bad luck in my case. So I now need to undo the screw for the earth connection as well. Right, so we've got the earth connection, which we need to reconnect to the frame later, and we have these two terminals here, and we need to investigate what is in those. Certainly one of them will have a thermal fuse, if not both of them. slide this along and see what we have. Okay, there's our thermal fuse, and I suspect it's going to be 185 Celsius. So it's marked KDKZ TF185 250 volt 10 amp. They are readily available. Get them on eBay and similar. So what's in the other one? Same again? Yes, it appears to be. And let's look at the continuity otherwise of those. And then I've got the problem of how am I going to connect up the replacements, because obviously you can't just solder onto these, can you? So I'll have to crimp them on in much the same way. It'll only be one of them's open, I should think. That one. Yeah, so that one's gone open circuit. And it's crimped on. So I'll have to uncrimp it and get a replacement. Tricky. The replacement's simple, but crimping them on is going to be a little fiddly. Well, you could solder it, you know, but no. Okay, so I've managed to just pull the wire off the top. I'll do the same at the bottom if I can. Okay, that one's snapped, so that's a little bit harder. That's a nuisance. Right, so I now need to obtain one of those and think about some sort of crimping solution. I might be able to recycle the one for the top, but the bottom one that's got the wire stuck in it is going to be a bit harder. Okay, today's a day that the components I've ordered from an eBay seller have arrived, which is some new thermal fuses plus some crimp connectors, albeit I don't have as many crimp connectors as I would have liked. It's just what they had in stock. So here are the thermal fuses. For some reason they're a lot shorter on the top than the bottom. I don't know why that is. And these crimps, I don't have the right crimping tool for them, so I'm going to have to experiment a little. This should hopefully be the same as the original TF185, 10 amp, 250 volt. I do wonder why they're short at the top there. Now there is one crimp connector that I was able to sort of salvage, so if I'm lucky that will fit in there and I can just recrimp that, and I only need to use a crimp connector for the other connector. That's actually looking promising. I have completely the wrong kind of crimping tool here, but I think I can get away with that for crimping the existing connector onto our new fuse. Okay, that's really actually very good. So now I just need to find a way to crimp onto the other end, which is where I'm going to have to use one of the crimp devices that came with the thermal fuses. Okay, I've managed to crimp both ends, but I can only say that if you do such a thing, please use the proper crimping tools and get a better job. But they're not going to come out. So, very important now, of course, put the sleeving back, because that's our insulation between these live terminals and the earthed housing. And so really we should use a Mega or similar device to do a earth voltage breakdown test, but I don't have such a device because I'm not, I don't normally do heavy electrical work, so we'll just have to do a resistance test with a multimeter. Okay, so two thermal fuses are in the middle where they were. Now it's a case of trying to reassemble all this back into those clips. So we have these clips that secure those and go through these slots here, and then we bend the tabs over to hold them in place. Now the difficulty is that these need to come through here, so we have to get enough slack that we can feed these all the way back and then back through to here while the element is fighting us. I've decided it'll actually be easier to refit the earth terminal first rather than trying to do that later when we've got all the extra wiring in. Okay, so let me show you what I've done here. So here are the parts which have to be clasped up on those brackets, and on the other side of the brackets are the thermal fuses, and I've got it so that the thermal fuses are sitting in those brackets, so they're not half up the cable or anything like that, but inside there. Now, why there's two effectively in series, we can't begin to imagine. I don't know why the manufacturer thought that putting two effectively in series, or one each end of the element, was important. I can't fathom that, but we have replicated it, so we have one thermal fuse sat in each of these sort of bracket clasp things, strapped to the housing, and now we can reassemble the housing. I've also got the earth wire, I'm glad I did that earlier, which is screwed in between those two thermal fuses, so the earth wire is connected here. So now I can try to put all this back together again. So we need to put the sort of housing basket thing back in, pull the wiring through. And there are these metal clasps here, or these little tangs here, which we need to slot into their locations to hold it in place, I think. So that would be these, got to be sort of folded in there, and then folded back on the other side. Same over here. Right, so folded those tabs back, so that's holding the metal frame in place. I think the next thing we need to do is, we don't want to fit the element yet, because we've got to refit the fan first. Flat washer, spring washer, and then left hand thread nut, which just feels weird. That's the element refitted. Right, so you remember that we had 50 ohms there. We've got on heat 1 to the neutral, and on heat 2 we now also have 50 ohms. So we're ready to and let's do a quick check here. Resistance to the earth point. So this is earth here. So heat 1 is open circuit to earth, and heat 2 is open circuit to earth. Good. And that was in an ohms measurement, not a continuity measurement, so it would measure mega ohms. Right, so we can start fitting the screws around here and refit the circuit board. Okay, so the exhaust port at the back has to go on before the PCB, because the PCB mounts on it. And we also have this, what I'm going to call bridge, at the top here. Okay, let me show you what I've done. So we have, well, I'm calling it the bridge. Notice it goes that way round. A lot of the cables run under here, but not all of them. And there are 8 screw slots in the bridge, but just the 4 inner ones are occupied. And then there's the PCB at the back, which has 4 screw holes, but this one here is not occupied. In fact, the PCB seems to be somewhat bent, really. It's not great. So I've reassembled all that as it was before, and I wanted to show you something in case you, like I, worry about something you don't need to worry about. Listen. Bit of a buzzing noise when you tap it. And I spent some time trying to work out if I'd put something together wrong, and it turns out to be the element. It's actually where the element here touches another loop. So if I tap it, it doesn't do it so much when it's on its back actually. When it's sat down here, I'm getting that buzzing noise. But if I stick my finger there between those, sort of around that area where the loops are, and then tap it, it doesn't do it. So it's nothing to do with anything I've done, that's just the design of the element tends to vibrate. Right there. Right there it is. Presumably it could also happen on this turn as well, but it's on this turn that's doing that buzzing noise. And to some extent it's doing it on the other element that I haven't even touched at this point here. So let's not worry about that. I think we're in a position we can put the front panel on and test it. Okay, we're close to testing it. So what I'm going to do is just override this side's draw input switch. There's a separate one for the other side, even though it's only got one draw, just so they could do a version with 2 drawers. And we're going to have a quick look with the thermal imaging camera to see if it heats up. Wish me luck. Let's hope it doesn't all go bang and the lights go out. So side 2, and we'll go for low temperature, and we'll just hit the start button. Nothing happens because the interlock, and instantly we can see the element heating up. Good. Switch it off like that, and that'll cool down. Okay, I can do some reassembly now, I think. I'll start with these rear screws, I think, because then that'll stop the chassis sliding out of the outer cabinet. Right, I had the cable snarled up behind the cabinet, so that's a mistake to not make. So these are the only black screws. I think all the others are silver. Okay, so that's all the screws refitted. We have no missing ones and no spare ones, so that's good. Just a case of refit this, which clips in. Top first or bottom first? This is the question. And the answer to that seems to be almost neither. I think the most important thing is to get the ends in first. This is built with 2 halves, which you can turn into one whole, whereas clearly this is also sold with 2 smaller units that come out separately. Okay, ready for some cooking. Well, I hope you've enjoyed us working on that Salter air fryer. If you're new to this channel, do pop by and have a look at some of the things I normally cover, like old video equipment such as this. Audio and video technology is my normal area. Now, I should say that while we were waiting to fix that unit, we actually bought a new one anyway. We bought a Tower. To be honest, we prefer it. There are a couple of things that were better about the Salter one. The Salter one's a bit shorter. The top of it is sort of not going to scratch so much, so you can put plates on it and warm them up, which is handy. And there's a really good feature on both of them where you can set one side to a different time than the other and get them to both finish at the same time. For example, if one member of the family is having fish and another member of the family is having a veggie pasty, you can have them all finish at the same time. But the Salter one, the side that's not presently cooking says hold, which is kind of logical. Whereas on the Tower one, it just doesn't progress the minutes, and that's less obvious what's going on. So we prefer the logic a little bit more on the Salter. But the thing is that the Tower one just cooks better. They're both about the same wattage, they're both about 3 kilowatts, because that's about roughly the maximum you can take from a 13 amp outlet. But the fan seems to work a lot better in the Tower one, and it cooks food quicker and more thoroughly than the Salter one. So the Salter one, we're going to put that to one side, and one of the boys will probably use that at a later date when they get their own pad. But right now we're going to use the Tower model, which, though it is bigger and costs a little bit more as well, it just does a better job. We also prefer the fact that it's got 2 individual drawers, which is great if you have a vegetarian person in the household and you want to keep the vegetarian food separate. Right, I'll do plenty more content in the future, mostly on audio and video technology, so have a look at the outro to this video and get to see some of the things I normally work on. Bye for now.
Is it hot?